Hi guys, welcome back to 7.2 example 1. Find the volume of the solid generated by revolving the region bounded by the graphs of the equations about the x-axis. So the first thing I need to pay attention to is what are we rotating about? We're rotating about the x-axis. So let me get a visual of this graph. Okay, let's say I have x second square root 4 minus x squared graph. So here is my shape, and it does hit at 2, and we're doing it for and also the y-axis or the x-axis, which is y equals 0. So here's my shape, my axis here, and let's see, here is my first curve to like this. And my second curve is y equals 0. Now if I rotated that about the x-axis, this will be mimicked here, and this will be mimicked here. Now if I notice, here my radius is different than here because we have an upper minus a lower. That is different than my upper minus my lower for this piece. So I am going to have to split this into two integrals. Keep in mind that we're doing infinitely many disks to find the volume of that 3D shape. And remember, this is not my function here. It's the reflection of my function. So I wouldn't do upper minus lower on this side to find the radius. I would do this upper minus this lower here. So let's split this into two integrals. So the first one is from -2 to 0, and the next one is from 0 to 2. Well, actually, I see that this is completely symmetrical. So instead of doing double the work, I'm just going to be 2 times the integral from 0 to 2, because I know this volume is symmetric to this volume. So it's going to be pi times big R squared, or I'm sorry, upper minus lower, which is x square root 4 minus x squared minus 0 dx. Pi r squared dx. And I'm doing double from 0 to 2 because it's symmetrical. So this is 2 pi times the integral from 0 to 2 of x square root 4 minus x squared squared dx. Well, this becomes, and this is volume we're finding, volume. Volume equals 2 pi integral from 0 to 2 of x squared times 4 minus x squared dx. So now I can distribute this. Volume equals 2 pi integral from 0 to 2 of 4x squared minus x to the 4th dx. So volume equals 2 pi 4x cubed over 3 minus x to the 5th over 5 from 0 to 2. Volume equals 2 pi multiplied by, what is this, 32 over 3 minus 32 over 5. So let's see. That's 32 times 5 minus 32 times 3, 64 over, so this is 2 pi times 64 over 15. So 64 times 2. This is 128 pi over 15 units cubed, because this is volume. So remember, you could have done two integrals, one from -2 to 0 and one from 0 to 2. But since it was symmetrical, I didn't want to do that unnecessary work. Let's try another example.